Okay, I'm going to go through some resistance welder questions now. Just wanted to reference it here in the module, or in the code, sorry. So here's where it starts, basically in the last page, or last little bit of page 313. First rule starts talking about supply conductors, again, just like transformer arc, but it starts off saying we're in an individual seam resistance welder or an individually automatically fed resistance welder. Okay, that's a key there. He's automatically fed. I'm going to turn the page over here. We're going to put the ampacity not less than 70% of the rated primary current. So think of that as like one of our duty cycles, except for it's not associated with another derating number. It's actually going to go in at 70% of the rated primary current. So that's if it's automatically fed. If it's not automatically fed or manually fed, then we're going to go to 50% of the rated primary current. Sorry. And then it says if we know what the actual duty cycle is, then we use these values just like we did for transformer arc, where all these percentages, these duty cycles, are associated with the duration, and we would just line those up. Okay, so for the first example here, again, these are just like right out of your blackboard. We also have another sheet. This is in your additional resources as well too. This is just for resistance welders. So again, it's a shortcut for the duty cycles. Talks about right here, if it's automatically fed, it's at 70%. If it's manually, it's at 50. And then again, if it's a duty cycle, we would use the chart or the numbers listed in the code. Okay, so we have this sheet too, so by all means use this if you like, just to get through it and get the idea behind it. So first thing we're going to look at is we're looking for an overcurrent, and it's a resistance welder. Its primary current is 80 amps. It's automatically fed. It's got a temperature termination of 75 degrees. So I have a conductor and a primary scenario, just like we did with transformer arc. Just our percentages are different. So if we look at the rule here, we're going through overcurrent protection. Just going to zoom out here so we can kind of see it all at once. So overcurrent protection, it's saying every resistance welder shall have overcurrent protection rated set at not more than 300% of the rated primary current. So just like transformer arc, that's our first one we're going to check. The primary current times 300% now instead of 2. Then we also check the conductor and times it, the conductor ampacity, times it by 300%. And the same rules apply. We're allowed to potentially go up as long as we don't exceed this primary calculation. Okay, so if we look at this question, we're going to want to compare the two just like we did. So now we have our primary current, which is 80 amps, times by 3, and we get 240 amps. Then we find the conductor. So first we take the primary current, times it by 0.7 because it's an automatically fed, so we're times it by 70%, and we get 56 amps. Then we go to table 2, and under the 75 degree column, because that's what it said here in the question, we get a number 6. That's good for 65 amps. So it's that ampacity there that we bring down, times that by 3 for the conductor portion. And then again, we choose the lowest of the two calculated values we get. So we're looking at 240 or 195, and we choose the lowest. But again, if we're using the conductor, which we are because it's lower, we might actually be able to go up and from table 13 as long as we don't exceed the 240. So when we go to table 13, we see that there is no 195, but we can go up to a 200 again. That's because we've chosen the conductor ampacity as the lower one, and we still aren't exceeding the 240. We still can't exceed that. Okay, but we're going to choose the lower of the two and then go to table 13 and then decide what we're going to do. So this would be the answer for this question, is we can go to a 200 amp overcurrent. Okay, so that's just sizing the overcurrent and technically sizing the conductor because we did that right here for one resistance welder. Now, if we look at a feeder conductor, so now we got one wire that's feeding, in this question, 4 welders, and we want to know what the size of the wire is. So again, in our question or our blackboard, we've given you this. But it's basically everything that we just did in the previous question for sizing conductors. So we don't have the conductors listed here, but these are the values of current that we would go to find our conductor from. And we don't happen to need those conductor ampacities, so we don't have them listed here. But we would take these, again, this is my primary, this is my duty, obviously my calculation. Okay, so that's where we're getting all those numbers. We need these calculated numbers though to find out the size of the primary feeder conductor. So if we look at the rule, it says so D here, where there is a group of resistance welders, the insulated supply conductor shall have an ampacity not less than the sum of the values obtained from item A, B, or C, so that's all our D rating based on duty or automatically or manually fed. So the largest welder of that, and 60% of the values obtained for all the other welders. Again, from A, B, or C, which is our calculated values. So we go back here and we look at all these calculated values. So these are all the values we got from these sub rules B, C, or A, B, or C. Okay, so that's what that rule was referring to. So we take 100% of the largest one, so that's that right there, because this guy's our largest. Then we take 60% of all the others. So if you want to write out in one shot, you can do it like this, but I say I'm adding all the other welders. So the next largest, doesn't really matter about the largest, we're going to add them all together, times it by 60%, and then add that to the 100%, and we get 76.6 amps. Then I go take that value to table 2, go on a 75-degree column, and I can choose a number 4. So I'd have a number 4 feeding this bank of these 4 welders. Okay, so not too terribly tough. These are almost a little bit easier than in some aspects, a bit easier because there's not as many percentages we have to worry about because they're all just going in at 60%. Okay, so this one's a little more straightforward than even the transformer arc. Then the last scenario we're going to get into is for the overcurrent protection for a group of welders. So that's where we're looking here. The maximum rating or setting of an overcurrent device protecting a feeder supplying a group of resistance welders shall not exceed a value calculated by determining the maximum rating or setting overcurrent device permitted by subrules 1 and 2 for the welder with the highest overcurrent protection. So right there is saying we're going to decide all the overcurrents for each welder and we're going to pick the largest overcurrent device, so a table 13 value. And then adding to this the sum of the ampacities calculated by 42014. So then we're going to use calculated values. So if we look at this little sheet here, just in case you wanted to use this again, here is where we're deciding the overcurrent device for each individual. Again, we're going to times them by 3 because it's 300%. We're going to choose the lowest again. When we did the feeder conductor, well, that example I just did, we take the 100% of the largest calculated, plus 60% of the remaining calculated. Then for the feeder overcurrent, which is what we're going to do next here, we select the largest overcurrent device. Again, that's from table 13. And then 60% of the remaining calculated conductor ampacities. And then we're going to get our total. So I have an example here from the blackboard where they've said that we have 3 welders. One has a primary of 85, 37, 32. Then their duty cycle. So now we can do the calculations, okay, because we need to find the conductor. So this is a little more involved, but this is literally right out of your blackboard, so you're going to have to be able to do this. So to get the calculated values, I'm going to go 85 amps times, and I need to find out what the duration is for the 20%. So if I go to the 20%, I'm 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 0.45 at 20%. So times 0.45. 37 times at 50%. You're at 0.71. 32 amps times, again, non-auto would be a manual. So we're looking at 50%. Or 0.5 for that guy. Okay, so we take 85 times 0.45, we get 38.25. 37 times 0.71, you get 26.27 amps. So these are all our calculated values. And then 32 times 0.5, 60. Okay, so now, again, we're at 75-degree temperature termination. Again, if it says that the welder's 90 and the breaker's 75, then choose the smallest always. Okay, so then the conductors for these, we're going to go to table 2, and we're going to find, alright, go to table 2 and find out all these conductor sizes. So again, under the 75-degree column, we're looking at, we want to find 38.25 amps, so that'd be a number 8. 50 amps, and then we're going to go 26.27, which would be this number 10 at 35. Sorry about the sniffling, I apparently have some allergies. And then 16 amps, we're going to go to number 14, which is good for 20 amps. Okay, so that's all the values we need. Now we're going to look at each individual welder and find its overcurrent. So welder 1 has a primary, so there's going to be a primary calculation and then a conductor. Primary is at 85 amps times 3, and then the conductor is 50 amps times 3. So if I go 85 times 3, we get 255 amps. This is 150. So again, we choose the smaller of the two. We'd go to table 13 and use 150 amp overcurrent for welder 1. Welder 2, we have our primary, and we have 37 amps times 3, and then the conductor ampacity of 35 equals, so 37 times 3 is 111. 35 times 3 is 105. So again, we're going to use this one here, but we have to go to table 13 and see which size breaker, or sorry, overcurrent device, and we're looking for a 105, and there's a 100 or a 110, and I can go up to a 111. So from table 13, I can definitely go up to a 110 amp overcurrent because I'm not exceeding the primary. Okay, so I went to table 13 and I was able to find I could go up to a 110 because I'm not exceeding this calculation here. That's okay, so I can go up to a 110. Then welder 3, our primary, and our conductor. To compare, again, choose the smaller, so our primary for that is 32 times 3, and then that's 96. Go to our 20 amps, that's from our conductor ampacity from right here. 20 amps times 3 is equal to 60, and I know that's a table 13 value, but we're going to pick the lower again, so table 13, I can use a 60 amp. So there's our breakers for each one. Now that rule kind of says, if we just look at this cheat sheet even, it says select the largest overcurrent device plus 60% of the remaining calculated conductor ampacities. Okay, and that's what it says in the rule here too, but I'll just lost my page there. So what I'm going to do is take the largest, so 150 amps, plus 60% of the calculated. So we've used this one because that was our largest, that's the 150 amps. Welder 1, so welder 2, so we're going to take 60% of the remaining, so the calculated value, so the 26 0.27 plus 16. So we take 150 plus 0.6 times bracket 26.27 plus 16, and I get 175.362 amps. So then I go to table 13 again, and I'm going to size my overcurrent off of that value. I got that 175. So I go to table 13, and I'm going to go down because that's a maximum. So I'd go down to a 175. So table 13, there's 175, so I'll be able to go down to 175 amp overcurrent. And that would be my answer. So again, very similar to transformer arc. This is probably the longer, harder question you're going to do. This question basically had us do everything. We had to size conductors, we had to size overcurrents, and then we had to find the total. The only thing we didn't do is find the feeder, because we did that in the previous example for a different set of welders. Okay, so definitely go through those questions, go through the blackboard. It'll put you through the ringer. Again, we separated the blackboard from transformer to resistance just so you can keep your head in one aspect, get it done. And then once you get that blackboard done, you're ready to do the third code test, which is due this week too. Okay, again, ask me if you got any questions. I'm happy to go through it.